So these two examples, they're pretty basic. I always have one function on top of another. But the question was raised earlier, what happens if they change, they intersect somewhere in the middle of our region? So let me draw you a picture to show you what we're thinking about here on this one. There we go. Maybe up a little bit here. So let's say my graph looks like okay, and then I'm going to have a function f of x that does, let's say it does something like this. And then, so this bottom one is going to be y equals f of x, and then this one's going to be and this one here is going to be g of x. And again, I want to go between a and b. So I go vertically up from x equals a, go vertically up from x equals b. So the area I want to calculate is between these two functions, between a and b, so I want to compute this little part, and this part. So look what happens. Remember, we're always concerned which one's on top and which one's on bottom, because they determine the order I write them down in. So if you look at the first shaded in region, the top function is f of x, and the bottom function is g. And then in the middle, they switch. G of x is on top, f of x is on bottom. And then the very third region, they switch again. F of x is on top and g of x is on bottom. So, what are we going to do when there's this switching going on? So the way we fix it in our statement before is now we're going to say that the area between the curves y equals f of x, y equals g of x, x equals a, and x equals b is going to be, still you integrate from a to b, but now you're going to put absolute values here, f of x minus g of x. And so what this is going to do for us, now we're going to have to compute the integral of each one of these areas separately, depending upon which function's on top and which function's on bottom. Okay. Again, area is a positive number, so we have to concern ourselves with which function's on top and which one's on bottom.